This is video 2 of the Psych 642 Mixed Designs assignment. So I will be picking up right where I left off at the end of video 1 with continuing to prepare for the analysis. The first thing that I want to do is just explore the data a little bit. So I'm going to do that using the by function in conjunction with the stat.dsc function, which gives descriptive statistics, and the list function, which allows me to just list the different predictor variables so that I can get the descriptive statistics of the outcome score, which here is depression score, in each of the different combinations of these predictor variables. So let's take a look at that. And you can see the output down here. It gives you the descriptive statistics. Oops, too far. For every single combination. So starting out with no exercise, no friends, and female, and doing all of the different combinations of those three variables. Next, I want to do the Shapiro test to see if all of these different groups are have a normal distribution. So once again, I'm going to use the by and list functions the exact same way I did for the descriptive statistics, just instead of doing the stat.dsc function to get those statistics, I'm going to do the Shapiro test function to get the results of the Shapiro test for each group. Alright, so let's take a look at all of those. So just kind of running through here fairly quickly, we can see that all of these groups so far do not have a p-value that is less than 0.05, so that means that they do not, their distributions do not deviate significantly from the normal distribution. It looks like we have one that deviates significantly from the normal distribution, so this may be an issue with running this specific test. So there are a few options to maybe correct for that, such as transformation of the data, using a more robust version of the test, or potentially using just some other type of tests to do an analysis to find what we're looking for. But for the purposes of this assignment, we're just going to soldier on and go through the steps of running this particular analysis. Alright, so now that we've tested the assumption of normality, taken a brief look at the descriptive statistics for the data, now I'm going to set up the contrast that'll be used for this model that we're going to use for the analysis. So I'm going to set up contrast for both the exercise variable as well as the friends variable. Specifically, I'm going to use orthogonal contrast for this, just because I want to see first if there's a difference between no exercise and exercise, and then if there's a difference between 15 minutes of exercise or 30 minutes of exercise. And then the same for the friends. I want to see if there's a difference between having no friends there and then having friends there, and then to see if there's a difference between having one friend or having two friends there. So in order to set up these contrasts, I'm going to create new variables for that represent each of these contrasts. So the first contrast will be no exercise versus exercise, and it's set up as 2, -1, and 1, and -1. And then the 15 minutes versus 30 minutes is set up as 0, -1, and 1. So everything is balanced there. So once those two variables are set, then I will use the contrast and cbind functions to bind those two variables into the contrast for the exercise variables. I'm going to go ahead and do that. Then I'm going to do the same thing for the friends variable. No friends versus friends has the same contrast set up. And then 1 friend versus 2 friends. And then using the contrast and cbind functions to bind those variables into the contrast for the friends variable. And now I can execute both of those variables to see if the contrasts were set up correctly. And if you look down here, it does look like everything is set up right. And then again, for the friends, once again, it seems like everything is set up correctly. So now that the normality assumption has been tested, the contrasts have been set up, we can go about actually building our model. So to build the model, I'll be using the LME function to create a multi-level model. So I'm using this instead of the EasyANOVA function, which is the alternative way of running this, simply because I find this to be the more flexible and easier way to do it, and it also circumvents the necessity to test and correct for sphericity. So that's why you won't see anything related to sphericity as far as testing assumptions or corrections throughout this analysis, because this specific way of doing the analysis does not require it. So the first thing that I'm going to do is create a baseline model that doesn't have any of the predictors in it, but instead just uses the intercept, which we can see here. Like I said, I'm using the LME function. The outcome score is the depression score, and then the only predictor in here is the intercept. I've also included this random aspect of the function, which actually specifies the fact that this is a within, or at least partly a within subjects design. So you can see that expressed here in the fact that exercise and friends are both listed here as predictor variables that are repeated measures. So it takes into account that information, which is why we don't have to test for sphericity. So I'm going to go ahead and run this to create the baseline model. And now I'm going to add one predictor after the other in a stepwise fashion, starting with exercise. So I'm going to do exercise, then I'm going to do friends, and then I'm going to do the interaction between exercise and friends. And then I'll add gender to that, and then the interaction between exercise and gender, the interaction between friends and gender, and then finally adding the three-way interaction in between exercise, friends, and gender. Rather than writing the entire LME function out again, I'm just going to continuously use the update function. So this first one, as you can see, is going to update the baseline function, keep everything the same, which is what this designation represents, but add an additional predictor of exercise. So I'm going to go ahead and do that. And then for the next one, I'm once again going to use update, but this time I'm going to be updating the exercise M model that I just created, and add friends, and so forth until we get to the last piece that will have the entire model that includes all of the predictors, both for the main effects as well as all the different interactions. All right, So now that the model has been built, I'm going to use the ANOVA function to compare the different models, to search for any significant differences. Okay, so we can see here that there was a significant main effect of exercise, as well as a significant main effect of gender. However, there does not appear to be a significant main effect of friends or any significant interaction effects in this model. So whenever I go to interpret this, I will be looking strictly at the main effects, because that's all that was significant. So now I'm going to use the summary of function to do the plan contrast that I set up. So whenever I look at the plan contrast, I'll specifically be looking at the contrast for exercise, the main effect of exercise, because that is the only thing related to a plan contrast that came up significant in the model. So I'm going to run that. But it will run all of the plan contrasts for the model, so I'll be able to kind of point out which ones I would be looking at if I did have some significant interaction effects. So we can see here all of the plan contrasts. From this, we can see that exercise, the no exercise versus exercise was significant. But the 15 versus 30 was not. And then, as kind of to be expected, the gender is significant. But because there was only the one comparison, that's to be expected, given that it came up significant in the main model. So if there were significant interaction effects, we would want to break down those effects by looking at all of these different plan comparisons that include the interaction effects. But none of that was significant for this specific experiment, so we will not delve into that any deeper. So now that the analysis is complete, I'm going to just create some graphs to illustrate what's going on a little bit better. I'm going to go ahead and do interaction graphs, even though they won't be of a whole lot of use for this particular experiment because there weren't any significant interactions. But I'm going to go ahead and do that. And then once again, just like anytime I make graphs, I'm going to do that using the ggplot function, using the XF data, specifying depression score to be the outcome, and then I'm going to have all of my different combinations in here of the predictive variables of exercise and friends, exercise and gender, and friends and gender, and then using the stat summary function to add in the graphical elements. So in this case, it'll be the points, the lines, and the error bars. And then the LABS function to add in the labels of the axes. Then I'm also going to use the facet wrap function for this one, which will produce kind of two different graphs side by side for the different genders, so we can see that three-way interaction. I'm going to run all of that, and then that will be the end of this video.